Hello everyone, welcome back. Hope you all are doing great. Guys, today in this video we are going to discuss packet flow. Packet flow between two end devices, packet flow over switch, packet flow over router and packet flow over firewall. In future video we can discuss packet flow over wireless networking devices like your access point and WLC. So guys, if you are a network engineer or if you are planning to become a network engineer, make sure you will watch this video till the end. And after watching this video, don't forget to share your feedback. Now, without wasting our time, let's begin. So guys, this topic is packet flow between end devices, our switch, our router and our firewall. Main goal of this video is to teach you the packet flow over switch, router and firewall. But before talking about the packet flow over switch, means how switch is going to process the frame, or how router is going to process the packet, or how firewall is going to process the traffic, let me tell you the packet flow between two PC, means end devices. It can be PC, it can be to PC, it can be to server, it can be to printer, to mobile phone, to a smartphone, any end devices. It can be any end devices. Okay, so let's say for an example, these two PCs are directly connected with each other. This is PC1 and this is PC2. You can see both are directly connected with each other. So both will have IP address from the same subnet. For an example, here IP address of this PC is 10.1.1.1 and IP address of this PC is 10.1.1.2. Right? MAC address of PC1 is, for an example, A, and MAC address of PC2 is B. Okay, so what I am saying, whenever I need to send any data from PC1 to PC2, how packet is going to flow, right? And to understand the packet flow here, you have to you should have knowledge about OSI model, right? OSI model and TCP/IP model. Then only you can understand the packet flow. Now let me send any data from PC1 to PC2. It can be my ICMP data, it can be HTTP data, it can be any file, video, text, anything from PC1 to PC2, right? So for an example, here PC1 has one data. This is the actual data. It can be file, video, text, anything. Now if the PC1 need to send it to PC2, guys, we have to attach the address. Now PC1 have to attach the address with this actual data, that this data is going to generated by PC1 for PC2, means source IP 10.1, destination IP 10.2, source MAC A, destination MAC B, right? For an example, when you are accessing the Google website, right, in the browser, if you are going to type www.google.com, again, your PC will first generate the actual data, that is going to be your HTTP request message for the server. But actual data cannot be sent directly to the server. Like suppose you have one letter, some information are there in this letter and you want to send it to your family member or to your friend. So you have to put this letter in envelope. You have to put this letter in one envelope, and on the envelope you are going to write the address, source address and destination address. So this envelope is what? This envelope is header. This is header, the extra information with actual data. And guys, your networking devices like switch, router, firewall, all these devices are going to forward the traffic on the basis of this header, extra information. These networking devices will not open your data. Some firewall can perform advanced inspection. In that kind, it can identify the application, which type of data it is, right? Advanced malware protection. But generally, these devices, your router, switch and firewall, is responsible to forward the traffic. So how these devices will forward the traffic? We are not going to learn the inspection on firewall. We are talking about the flow, packet flow, how it will forward the traffic from one interface to another interface. So to forward the traffic from one interface to another interface, this header information will be checked at each and every device. It can be switch, it can be router, it can be firewall. The extra information header. Right? Now PC1 need to add header here, extra information like port number, right? For an example, port number is 1025. Source port, destination port, let's say 443. It is HTTP S traffic. Then source IP 10.1.1.1, destination IP 10.1.1.2. After that, source MAC A, destination MAC. And guys, see in the IP header, or in this is TCP header, right? TCP. This is IPv4 header. IPv4 header. In the IPv4 header or TCP header, there will be many more informations. Many more informations will be there in the TCP header, like the sequence number, acknowledgement number, checksum. In the IP header, TTL value, protocol value, sequencing, right? So those fields will be also there. But to understand the packet flow, these two fields like source port and destination port is important in the TCP header, and source IP and destination IP is most important in the IPv4 header. Similarly, at layer 2 in the Ethernet header, there will be source MAC, destination MAC. There will be type field also, but I am not assuming type field here now. Destination MAC. Now question is destination MAC will be what? B. How PC1 will get to know about the destination MAC, right? Before destination MAC, how PC1 will get to know about the destination IP? The destination IP address is 10.2. So guys, you are going to tell to PC1, right, that okay, this is the file or this is the HTTP request. Just send this request to Google server, right? So you said na google.com. Your machine is going to resolve the domain name into IP address. Means logically you are telling to your device about the destination IP address. If I am saying ping 8.8.8, means I am telling to my device that 8.8.8 is one server somewhere on the internet. Just check reachability to that server. So we are telling about the destination IP address to the PC, to the device. But what about the destination MAC? For the destination MAC, guys, all networking devices maintain a table, right? To store the MAC address with IP address, all networking devices maintain a table called ARP table. My PC will check ARP table. Which table? ARP table, Address Resolution Protocol table. In the ARP table, it will find the destination IP address 10.1.1.2. What is the MAC address of this IP address? And there are two possibilities. Maybe in the ARP table, entry will be there, right? Like the MAC address of 10.2 is B, then it's good. PC will directly put the destination MAC B here. But if there is no entry for 10.1.1.2 in the ARP table, then first PC is going to complete this ARP process. Then your PC will put the actual data on hold and it will generate the ARP request for 10.1.1.2. After that, 10.2 means PC2 will generate ARP reply, and once your PC1 will receive the ARP reply, it will add this MAC address in their table, in their ARP table. This is not for PC, this is for every device, every networking devices. All networking devices maintain ARP table. If you don't know the ARP working, like how ARP protocol works, then watch my ARP video. Done? So here MAC destination MAC address is B. Now see in this complete traffic, this is the now data, the actual data plus header, right? These are header, extra information, right? This is the actual data for PC2. Now my switch, let's say there is one switch between PC1 and PC2. So switch will forward traffic by checking the header. Router will also check header. Firewall will also check header. Okay. After that, PC1 is going to forward it to PC2. PC2 will receive the traffic on this interface at layer 1. At layer 1, at physical layer. Then physical layer will convert it from bits to frame and hand over it to data link layer. Data link layer is going to match destination MAC address. The destination MAC address is B or not. My MAC address is or not. If the destination MAC address is the MAC address of PC2, it will accept the traffic. Otherwise, it will discard. In two cases, PC2 will accept it, or any networking device will accept it. If the destination MAC is the MAC address of receiving device, or the destination MAC is broadcast. Because if it is broadcast, then it can be for me as well. Okay, so it is going to accept, because destination MAC address is the MAC address of PC2 only. After that, by checking the type field in the Ethernet header, it will identify the upper layer protocol. Upper layer protocol is IPv4. So at PC2, your ARPA protocol will hand over the traffic to upper layer, network layer, to IPv4 protocol. IPv4 protocol is similarly going to check destination IP address. The destination IP address is my IP address or not. So yes, if destination IP address is my IP address, I will accept. Or if it is broadcast, then also I will accept. Otherwise, it will discard. But if guys there is router or switch, let's say one switch is receiving the same traffic, destination MAC, B, switch. So here switch will accept all the traffic. Doesn't matter what is the destination MAC address. Right? Because switch is a networking device to connect multiple LAN devices. Switch need to forward traffic between multiple computers, multiple servers, multiple printers, multiple mobile devices. Similarly, if we have router and router is receiving the traffic, doesn't matter what is the destination IP address, every time it will accept. But for the end devices, destination IP or destination MAC should be the receiving device address or broadcast, then only it will accept. But router switch can accept all traffic. Doesn't matter what is the destination IP, what is the destination MAC address. After that, it will verify that with their table, and then it will take forwarding decision. I'm going to show you that, don't worry. So this is my packet flow between two devices. PC is going to generate the actual data. After that, it is going to add some extra information, headers. It will attach some extra information with data. What is the main purpose of these extra information, guys? Just to send the actual data to the correct destination. My requirement was just sending this data from PC1 to PC2. That's it, correct? So we have added these all extra information to send the data, actual data, to PC2. So PC2 will remove these all extra informations first, and after that it is going to hand over the actual data to HTTPS protocol. At layer 2, it will remove Ethernet header. At layer 3, it will remove this header. At layer 4, it will remove this header, and after that it will hand over this actual data to application layer protocol, which is your HTTPS. This is so simple, right? Because in TCP/IP model we have total 4 layers. Transport for the source port, destination port, IPv4 or IPv6 for the source IP, destination IP, and Ethernet header. Right? Which protocols are adding these extra information? So guys, Ethernet header will be added by ARPA protocol. IPv4 header or IP header can be added by IPv4 protocol, or it can be added by IPv6 protocol. Transport layer header can be added by either TCP protocol or UDP protocols. As a network engineer, you should have knowledge about the port number of all application layer protocols and which services, which protocols they are using at transport layer, TCP or UDP. Right? So whatever information PC1 is going to add at layer 3, PC2 will remove that information at same layer. Whatever information PC1 is going to add at layer 2, PC2 will remove that at same layer. Same thing will happen for servers as well. If this is the PC and here is one server, let's say Google server, IP address 10.1.1.2, PC IP 10.1.1. right? So data is there, that is my HTTP request message. Then source port number 1025, destination port number 443, source IP 10.1, destination IP 10.2, source MAC A, destination MAC B. This is the actual data. It will forward to PC2 or Google server. Google server will receive it at layer 2. First of all, it is going to check destination MAC. Destination MAC is B. It is matching. This is for me. Just remove this header and check upper layer information. At network layer, destination IP is 10.2. Yes, this is my IP address. Accept it and remove this header. At layer 4, 443 port number. Is 443 port number running over here? 443. If it is running, then accept. Otherwise, discard it, drop it. And if this port number is not running on the server, then it will send the reset message. You know this. Reset message to PC. If this port number is enabled, then it will accept and it will hand over the actual data to HTTP protocol. Hope it is clear. This is packet flow between two end devices, and this data can be anything. It can be your video, text, file, HTTP request, DNS, DHCP, Telnet, SSH, SNMP. It can be any data, voice, anything. Done. Now what I am assuming that, guys, there are so many. There is one network of a company. Let's say my company has around 50 employees. So these all employees are connected together through one switch, right? We can connect all the employees PC through switch or maybe through access point. In another video I will show you the packet flow over access point as well, don't worry. But here I am talking about wired network. So PC1, let's say PC1 MAC address is A, PC2 MAC address is B, PC3 MAC address is C, and PC4 MAC address is D. These all PCs are connected through switch. Now they all can communicate with each other. So what is switch here? Switch is a centralized device which is used to connect multiple end devices together or multiple networking devices together. Right? Now, how switch will make communication between two end devices? Let's say PC1 and PC2 want to communicate. Here IP address of PC1 is 10.1.1.1 and IP address of, let's say, this PC is 10.1.1.4. So how switch will forward traffic between PC1 and PC4? For that, switch is going to maintain one table called MAC address table. MAC address table, or you can say CAM table. CAM table. Question: how switch will build the MAC address table? Guys, again, two ways are there: static and dynamic. Switch can build MAC address table statically as well as dynamically. Statically means what? Statically means statically you are going to tell to switch that, brother, your interface this one, let's say port number 1, port number 2, port number 3 and port number 4. So statically I am going to tell to switch 1, I am going to make one entry in their MAC address table that on your port 1 a device is connected whose MAC address is A. On your port number 4 a device is connected whose MAC address is D. Getting my point? On port number 1 a device is connected whose MAC address is A. On port number 4 a device is connected whose MAC address is D. Statically we can make this entry. Guys, if you need the practical of this, you can let me know in the comment section. I will show you practically as well. I will show you practically how we can make the entry in the MAC address table of switch, or how switch will build the MAC address table dynamically. Now, switch have the entry, or in the dynamic, how switch is going to learn the MAC address, or how it is going to build the MAC address table. In the dynamic method, guys, whenever switch receives the frame on the interface, it learns source MAC address. For an example, I am on switch and I have received one traffic on my port number 1, or let's say 0/0. On 0/0 interface, I am receiving one traffic where source MAC is A, destination MAC is D. So once I will receive the traffic on my interface, I am going to learn the source MAC. The first function of switch is learning source MAC address, right? So let's say here another example. We have one switch here, one PC whose MAC address is A, one another PC whose MAC address is B. So if PCE want to send some data to PCB, again source IP 10.1, destination IP 10.2. So PC1 will generate the data, actual data. After that, with the actual data, it is going to attach the extra information, means headers. So source port number will be there 1025, destination port 443, source IP 10.1, destination IP 10.2, source MAC A and destination MAC B. And PC will forward it to switch. When switch will receive the traffic on this interface, port number 1, it is going to make entry. Hey, I am receiving the frame on port number 1. And what is the source MAC address E? That means the device which is connected on this interface has a MAC address. Has the MAC address A. Right? On my port number 1, a device is connected whose MAC address is A. So it will make the entry like this. Port number 1, MAC address A. Very good. Now, if PC1 want to send some data to PC4, PCD, again PC1 will generate, guys, data, HTTP request or any data file, video, text. After that there will be port number, source port 1025, destination port 443, TCP header. Then IP header, source IP 10.1.1.1, destination IP 10.1.1.2. Source MAC A, destination MAC D. Very good. And after that, this this PC will forward it to switch. Good. On switch will receive the frame on this interface. What switch will do? Switch is going to update their MAC address table, right? Because by default MAC aging time is 300 seconds. After 300 seconds, it is going to flush this entry. For the dynamic, there will be one timer that is called MAC aging timing. By default MAC aging time is 300 seconds. So it is going to update the entry for source. That okay, so on port number 1, source MAC is A. If it is receiving any frame with different MAC address, let's say here now I have connected new PC whose MAC address is P. So source MAC is going to be P now. And once switch will receive the frame with P MAC address, it is going to update their MAC address table. The first function of switch. The second function is, guys, forwarding. Second function is forwarding. Now, after updating the table, after learning the source MAC address, switch is going to check destination MAC. Destination MAC is D. Again, switch will look up their MAC address table that, hey, for D MAC address, what is the port? What is the port number for D MAC address? Where the PC whose MAC address is D is connected. Where D MAC address PC is connected. D MAC address PC is connected on port number 4. So switch will forward the frame from this interface, PC4. Similarly, if destination MAC is C, then it will forward from this interface. If destination MAC is B, then it will forward from this interface. So switch will never check, guys, IP header, transport layer header or the actual data. Switch is only going to check layer 2 header. That's it, to forward the traffic. Switch even don't know what is the IP address in the frame. No, nothing. If the traffic is for switch, let's say on the switch we have one SVI for VLAN 10 and MAC address is P. MAC address is P. So if switch is receiving a frame where destination MAC is P, then only switch is going to check layer 3 header. Otherwise, switch will not check layer 3 header. Because this time destination MAC address is the MAC address of switch itself. So this is the packet processing by switch. How switch is going to forward the packet. Now let me tell you about the router. Now guys, here I have one switch. Here some PCs. let's say MAC address A, MAC address B, 10.1, 10.2, and here I have one router R1, and you know router is used to connect multiple networks together, like switch is used to connect multiple n devices together. Similarly, router is used to connect n devices, two or more different networks together. Here MAC address is C, here MAC address is D. IP address 20.1, here IP address is 20.2. So you can see router is connecting two different subnet, 10.1.1.0/24 and 20.1.1.0/24. It is connecting two different networks. Question: how router is going to know process the traffic? How router is going to forward the traffic? Guys, router maintains routing table to forward the traffic. Router maintain routing table to forward the traffic. Question: how router will build the routing table? So you have to configure one IP address on this interface, one IP address on this interface. Let's say this is 0/0 interface, this is 0/1 interface. Fast Ethernet 0/0, fast Ethernet 0/1. And for an example, here I have configured IP 10.1.1.100, and here I have configured IP 20.1.1.100. This IP address belongs to this subnet, and this IP address belongs to this subnet. Also, we will configure this IP address on F0/0 of router 1. It is going to make one entry in their routing table. Router maintain routing table, switch maintain MAC address table to forward the traffic. It will make one entry in the routing table that okay, on my F0/0 interface, a network is connected. Which network? It will calculate the network ID of this IP address. This is IP address. You will also define the subnet mask 255.255.255.0. It will calculate the network ID. Network ID is going to be 10.1.1.0. So it will install this network on F0/0 interface 10.1.1.0. Similarly, on this interface F0/1, there will be one network 20.1.1.0/24/24. Done. This is directly connected network. These two are directly connected. The network which are directly connected with router are running on the router. If there are some indirectly connected network, then you have to configure routing. In that case, you will configure routing. That is not the basic packet flow. Today, agenda is to understand the packet processing on these networking devices. In another video, definitely if you will request to include the routing concept on router in packet flow, I will make one separate video for that. So if we have the indirectly connected network, not directly connected network, then we have to configure routing. Now, these two are directly connected networks in the routing table of router. Now, if PC E want to communicate with PC C, PC A will again generate data, actual data, source port number 1025, destination port number 443. Source IP address 10.1, destination IP address guys this time 20.1. Now destination is not in same subnet, destination is in now different subnet. And you know, when destination is in different subnet, then destination MAC address will be the MAC address of default gateway, not the MAC address of destination device. Right? So source MAC is going to be A and destination MAC is going to be what? The MAC address of gateway. Let's say here MAC address is P, here MAC address is Q. So destination MAC will be P. Right? Again, these are extra informations and this is my actual data. Now PC will forward it to switch. Switch is going to only check this layer information, layer 2 information to take forwarding decision. It will update the MAC address table and then it will forward from this interface, because switch is going to learn P MAC address on this interface. And after that, router will receive over here. Now when router will receive the traffic, again first router will definitely check layer 2 information. But on the basis of layer 2 information, router cannot forward the traffic like switch. So at layer 2, router will accept the traffic first if the destination MAC will match. Again on the router, destination MAC address should be the MAC address of router receiving interface or broadcast, then only it will accept, otherwise it will discard. So destination MAC is P, you can see, which is the MAC address of router receiving interface. It will accept at layer 2, and now router is going to remove this header, layer 2 header, and it will check layer 3 information. Destination IP address. Destination IP address is 20.1. Now router will compare this destination IP address with their routing table. That where is 20.1? Is there any route available in my routing table where this destination IP address is matching? Yes, destination is 20.1.1.1. I have one network 20.1.1.0/24. On which interface? On F0/0 interface. So router is going to forward the traffic from this interface F0/1. But before forwarding the traffic, guys, router have to add layer 2 header, because it has removed the layer 2 header. So now router is going to add new layer 2 header. See, router have not checked the data. Router have not checked the data. Router have not checked the layer 4 information, source port number 1025, destination port number 443. It has only checked layer 3 information, source IP was 10.1, destination IP is 20.1. Even router is not going to change anything in source IP and destination IP. Router will only change one thing in the IP header, that is TTL. It will decrement in TTL by 1. It will decrement in TTL by 1. Otherwise, all the informations will be seen in the IP header, network layer header, and it will add the new layer 2 header. In the new layer 2 header, source MAC will be the exit interface MAC address, which is Q, and destination MAC will be the MAC address of destination, this PC 20.1 C, and it will forward to switch. Again, switch is going to update their MAC address table, and then it will take forwarding decision. Like this, router is going to forward the traffic. So how router forward traffic? Router compare destination IP address in the packet with their routing table. It finds exit interface and forward the traffic from exit interface. This is the packet flow on router. Packet processing on router. Switch maintain MAC address table to forward the traffic, and router maintain routing table to forward the traffic. How switch process the traffic? How switch process the frame? When switch receive the frame on interface, it update their MAC address table. First it updates their MAC address table, and how? On the basis of source MAC. On the basis of source MAC address, it will update their MAC address table, and on the basis of destination MAC, it will take forwarding decision. Now if I will talk about the router, so when router receives the traffic, it checks layer 2 header first. After that, it removes layer 2 header and checks layer 3 header. In the layer 3 header, it will check the destination IP address. It will compare the destination IP address with routing table. It will find the exit interface in the routing table, and then according to the exit interface, it will add new layer 2 header and then forward it from exit interface. And guys, any device which can rewrite the layer 2 header, what I am saying, any device which can rewrite layer 2 header, Ethernet header, like router here. Router is removing the layer 2 header on the receiving interface and adding new layer 2 header on the exit interface. So all the networking device which has capability to rewrite layer 2 header will always decrement in TTL by 1. All the devices who has capability to rewrite the layer 2 header, means removing the Ethernet header and adding the new Ethernet header, On the receiving interface, it will remove the Ethernet header. On the exit interface, it will add the new Ethernet header. So all the devices who have capability to rewrite layer 2 header will decrement in TTL by 1. And hope it is clear the basic packet processing on router. Now let me tell you the packet flow or packet processing on firewall, guys. Now here let's say I have one firewall. Firewall, router, R1, R2, and then switch, and devices. Here my subnet is 10.1.1.0/24. Here my subnet is 20.1.1.0/24. First of all, to understand the packet flow on firewall, guys, you have to understand the John concept. Johns. What is John? You must have heard about DMG John, inside John, outside John, trusted John, untrusted John. So John is nothing but the group of interface. Grouping of interface is called John, right? Maybe this interface is going to be my LAN 1 John. This interface is going to be my LAN 2 John. After that, you have similar thing like routing lookup on router. Firewall will also look up for routing table. First Jones, then routing table. 1 minute, getting one call. Yes, John's concept. Then here you have to understand the policies concept. Policy means similar like ACL, which traffic are allow, which traffic are deny. Then you have to understand the routing lookup, and after that you have to understand the stateful behavior. What is the stateful behavior? A stateful behavior is one, guys, advanced concepts of traffic forwarding on the firewall, right? So for an example, I am going to design one network here. Let's say I have some LAN users. This is my switch. Here are some LAN users. This switch is connected with one router R1. Router 1 is connected with one firewall. And firewall is finally connected to internet, INET. On the internet, we have one Google server, it. So on the firewall, first of all, we'll define the zone. Let's say this is my inside zone. This is my outside zone. Then routing lookup, you already know, similar like router. Policy, you already know the ACL policies. So now you can understand the packet flow on firewall. See, when this user, let's say IP address 10.1.1.1 want to access 8.8.8, it has generated any data HTTP request for 8.8.8, source port 1025, destination port 443, source IP address 10.1.1.1, destination IP address 8.8.8.8, source MAC, PC A MAC address, destination MAC, gateway MAC address. It will forward to switch. Now you know how switch forward traffic, packet flow on the switch with the help of MAC address table. It will update the table first, MAC address table first, when it will receive the frame. Then on the basis of destination MAC, it will take forwarding decision. When router will receive the traffic, it is going to remove layer 2 header. It will look up the routing table. It will again, in the routing table, it will find the exit interface. Again, it will add the new layer 2 header and forward the traffic to firewall. When firewall will receive the traffic on this interface. First of all, it is going to identify the zone. The interface where I am receiving the traffic is in which zone. This is called ingress zone. This is ingress zone. Right? So ingress zone is inside zone. Ingress zone is inside zone. After that, firewall is going to look up routing. That okay, what is the destination IP address? First, identify the ingress zone. Ingress zone is inside zone. Then it will look up the routing table to find the route. In the routing table, route is there or not? Same routing table like router. We are on the firewall, guys. We will have one default route towards internet. Right? So destination IP address will match in this default route. Now it is going to firewall is going to identify the egress zone. Okay, if the destination IP address is matching in this route, so this route, this network is connected on which interface? This is connected on this interface. In which zone this interface is now? Now my exit interface is in which zone? Egress interface is in outside zone. So when firewall is receiving the traffic, first it will identify ingress zone. After that, it will look up routing table. In the routing table, it will find the exit interface and it is going to identify the egress zone. Right? So this is the first step. Identify ingress interface and egress interface. Once firewall will identify the ingress and egress interface, firewall is going to look up policy. Firewall is going to look up policy. In the policy, this traffic is allowed or not. Right? Means firewall now know the traffic want to go from ingress interface to or egress interface. Means inside zone to outside zone. Let me check the policy. Traffic from inside zone to outside zone is allowed or not. Not only the zone, this source 10.1 source and 8.8.8 destination from inside zone to outside zone are allowed or not. Even the port number, source port number 1025, destination port number 443, source IP 10.1, destination IP 8.8.8, source zone, ingress, inside zone, destination zone, outside zone, egress zone, outside zone. Now it will check the policy that this traffic is allowed or not. These all things should be allowed. Port number, source port, destination port, source IP, destination IP, and zone, from this zone to that zone, inside zone to outside zone. If traffic is allowed, then firewall will build one connection table. It is going to maintain connection table. It will make one new table called connection table, or you can say stateful table, active table, where it will store all the active connection. Right? Means this is the source, this is the destination, this is the ingress interface, this is the egress interface, this is the source port, this is the destination port, and after that firewall will forward the traffic to internet. Now when same user will generate again another traffic for the same destination, same source port, same destination port, same source, same destination IP, then it is not going to perform these all checks again. It will directly check the connection table. In the connection table, if the entry is there, then on the basis of that it will take forwarding decision. This is the packet flow over firewall. Identify the zone, first step. Which zone? Ingress zone. The receiving interface is in which zone? By looking into the routing table, identify the egress zone. After that, check the policy that this traffic is allowed or not. According to the predefined policy, configured policy, it will take decision. Right? So these are the basic packet processing on your switch. between two end devices, our router and our firewall. But guys, these are the basic, not advanced, even not in detail, even we have not discussed the routing. So if you need the advanced packet flow, like each and every step, our switch, our router, our firewall, and devices, you can let me know in the comment section. If you need the packet flow our wireless networking devices, our access point or WLC, then also you can let me know in comment section. Hope the basic packet flow is clear to you. And guys, if you have any question related to this topic or any other topic, then also you can let me know in the comment section. We are checking, keep checking your comments. If I need to make more videos to clear your doubt, definitely I will make more videos. But if the video was helpful for you, if you have learned something from this video, then guys, please hit on like button. Please hit on like button, and the most important thing is share your feedback. Your feedback is a lot for us. For me, your feedback is everything. Right? So if you are going to give me the negative feedback, definitely I will work on your feedback and try to improve the quality. If you are going to share the positive feedback, the video was helpful for you, everything is clear, share your positive feedback. It will motivate me to make many more videos in future. Okay, so don't forget to share the feedback, hit on like button, and if you are new on the channel, if you are learning from if you are in the networking industry and my language videos are helpful for you, if you are learning, then subscribe this channel, click on bell icon, so that whenever I will upload any new video, you will get notification. That's all for today guys. We'll meet soon in the next video. Till then, stay safe. Bye bye. That's all for today. Thanks for watching.